Redox titration does not require indicator because solutions change colors when oxidation states change. This titration involves both reduction and oxidation simultaneously. In this lesson, we will discuss molar gas volume. In this lesson, we will discuss molar gas volume. In this lesson, we will discuss volumetric analysis. Redox titration does not require indicator because solutions change colors when oxidation states change. This titration involves both reduction and oxidation simultaneously. Click on the Enter button to follow up on a worked example. An iron tablet containing iron 2 sulfate was analyzed using 0.1 molar potassium manganate 7. The mass of iron tablet was 1.30 grams and was dissolved in 400 cubic centimeters of dilute sulfuric acid. 20 cubic centimeters of solution required, 12.0 cubic centimeters of potassium manganate 7 for complete reaction. Calculate the percentage of iron present in the iron tablet. Iron is equal to 56. The equation for the reaction is: Step 1. Calculate the mole of potassium manganate 7 used. Number of moles of potassium manganate 7 is equal to molarity of potassium manganate 7 multiplied by volume in liters, which is equal to 12.0 multiplied by 0.01 divided by 1000 is equal to 0.00012 moles. Step 2. Using mole ratio between manganate ions and iron 2 ions as shown in the equation, we obtain the number of moles of ions in iron 2 ions. The mole ratio of manganate ions to iron 2 ions is 1 to 5. Therefore, the number of moles of iron 2 ions will be 5 divided by 1 multiplied by 0.00012, which is equal to 0.0006 moles. Step 3. Calculate the number of moles of iron 2 ions in 400 cubic centimeters. If 20 cubic centimeters of iron 2 ions contains 0.006 moles, then 400 cubic centimeters of iron 2 ions contains 400 cubic centimeters multiplied by 0.006 divided by 20, which is equal to 0.012 moles. Step 4. Work out the mass of the iron in one tablet. We know that number of moles is equal to mass given in grams divided by relative atomic mass. Then mass given is equal to number of moles multiplied by relative atomic mass. Therefore, mass of iron is equal to 0.012 multiplied by 56, which is equal to 0.672 grams. Step 5. Calculate the percentage of iron in the tablet. Percentage of iron in the tablet is equal to 0.672 multiplied by 100 divided by 1.30, which is equal to 51.69%. In this lesson, we will discuss molar gas volume. The atomicity of a gas refers to the number of atoms that make one molecule of the gas. The atomicity of the noble gases, helium, neon, and argon, is 1. They are monoatomic. The atomicity of oxygen gas, nitrogen gas, and hydrogen gas is 2. They are diatomic. Ozone is triatomic. Find the volume of 1 mole of hydrogen at standard temperature and pressure. The volume of 1 mole of a gas is called molar gas volume. At standard temperature and pressure, this molar gas volume is taken to be 22.4 cubic decimeters for all gases. At room temperature and pressure, the molar gas volume is 24.0 cubic decimeters. Remember, gases have mass and volume. 1 mole of any gas occupies 22.4 cubic decimeters at standard temperature and pressure and 24 cubic decimeters at room temperature and pressure. Example: how many moles of oxygen gas are there in 48 cubic centimeters of oxygen at room temperature and pressure? Molar volume at room temperature and pressure is equal to 24 cubic decimeters. Step 1. 1 mole of oxygen gas occupies 24,000 cubic centimeters at room temperature and pressure. X mole of oxygen gas occupies 48 cubic centimeters at room temperature and pressure. Step 2. X multiplied by 24,000 cubic centimeters is equal to 1 multiplied by 48 cubic centimeters. X is equal to 1 multiplied by 48 cubic centimeters divided by 24,000 cubic centimeters. X is equal to 0.002 moles. Equal volumes of gases, though with different molar masses, contain same number of particles. This law was developed by Amedeo Avogadro's law, which states that equal volume of all gases at same temperature and pressure contain the same number of particles. It's usually represented by the letter L, where L equals to 6.023 multiplied by 1023 particles. Click on the Enter button to follow up on a worked example. How many molecules are there in 1.2 liters of hydrogen gas at room temperature and pressure? Molar gas volume at room temperature and pressure is equal to 24.0 cubic decimeters, which is equal to 24.0 liters. L is equal to 6.023 multiplied by 10 to the power of 23. Step 1. 24 liters of gas contain 6.023 multiplied by 10 to the power of 23 molecules. 1.2 liters of gas contain Y molecules. Step 2. Cross-multiply and solve for Y. Y is equal to 1.2 multiplied by 6.023 multiplied by 10 to the power of 23 divided by 24, which is equal to 0.3 multiplied by 10 to the power of 23 molecules. In standard form, this value becomes 3.0 multiplied by 10 to the power of 22 molecules. Click on the Enter button to follow up on a worked example. How many atoms are there in 300 cubic centimeters of nitrogen gas? At room temperature and pressure, L is equal to 6.023 multiplied by 10 to the power of 23. Remember, nitrogen is diatomic gas. Step 1. 24,000 cubic centimeters of nitrogen atom contain 6.023 multiplied by 10 to the power of 23 molecules. 24,000 cubic centimeters of nitrogen molecule contain 2 multiplied by 6.023 multiplied by 10 to the power of 23 atoms. 300 cubic centimeters of nitrogen gas contain Y atoms. Step 2. Cross-multiply and solve for Y. Y is equal to 300 multiplied by 2 multiplied by 6.023 multiplied by 10 to the power of 23 divided by 24,000, which is equal to 1.5 times 10 to the power of 22 atoms. The results obtained conform to a law which describes the behavior of gases and is referred to as Gay-Lussac's law. When gases combine, they do so in volume which bear a simple ratio to one another, and to the volume of the product is gaseous. Click on the Enter button to follow up on a worked example. Click on the Enter button to follow up on a worked example. Click on the Enter button to follow up on a worked example. 100 cubic centimeters of hydrogen was exploded with 100 cubic centimeters of oxygen. What is the volume of the unreacted gas at room temperature and pressure? Step 1. Write a balanced equation. Step 2. 2 volume of hydrogen gas reacts with 1 volume of oxygen gas. 100 cubic centimeters of hydrogen gas reacts with Y volume of oxygen gas. Step 3. Cross-multiply and solve for Y. Y is equal to 100 multiplied by 1 divided by 2, which is equal to 50 cubic centimeters of oxygen gas is equal to 100 minus 50, which gives us 50 cubic centimeters. In this lesson, we will discuss reacting masses and volumes. Ionic equation represents a chemical change by means of ions. Remember, ions are charged particles, that is, charged atoms or radicals. Write ionic equation for the reaction between calcium carbonate with dilute hydrochloric acid. Step 1. Write a chemical equation. This is also called a stoichiometric equation. Step 2. Check the substances which remain in the same state and whose ions are free. Consider the reaction between lead-2 nitrate solution and potassium iodide solution. At the start, all the ions, potassium ions, iodide ions, lead-2 ions, and nitrate ions are free to move. On mixing potassium iodide solution, lead-2 nitrate solution, lead ions combine with iodide ions to form a yellow precipitate of lead-2 iodide. Click on the Enter button to follow up on a worked example. Click on the Enter button to follow up on a worked example. Click on the Enter button to follow up on a worked example.